Good day, everyone. I am Stephen Lloyd R. Hubay, and our group is going to discuss Chapter 5 of this course, which is forecasting. By the end of this chapter, we will be able to understand and know when to use various families of forecasting models, compare moving averages, exponential smoothing, and other time series models, seasonally adjust data, understand Delphi and other qualitative decision-making approaches, and lastly, compute a variety of error measures. Before we proceed, let us first define what is forecasting. So forecasting is the process of making predictions or estimates based on past and present data. There are many ways to forecast the future. In numerous firms, especially smaller ones, the entire process is subjective, involving seat-of-the-pants methods, intuition, and years of experience. There are also quantitative forecasting models such as moving averages, exponential smoothing, trend projections, and least squares regression analysis. The following steps can help in the development of a forecasting system, while steps 5 and 6 may not be as relevant if a qualitative model is selected in step 4. Data are certainly necessary for the quantitative forecasting models presented in this chapter. So these are the 8 steps. First, determine the use of the forecast. What objective are we trying to obtain? 2. Select the items or quantities that are to be forecasted. 3. Determine the time horizon of the forecast. Is it 1 to 30 days, 1 month to 1 year, or more than 1 year? Fourth, select the forecasting model or models. 5. Gather the data or information needed to make the forecast. 6. Validate the forecasting model. 7. Make the forecast. And lastly, implement the results. These steps present a systematic way of initiating, designing, and implementing a forecasting system. When the forecasting system is to be used to generate forecasts regularly over time, data must be collected routinely, and the actual computations or procedures used to make the forecast can be done automatically. There is seldom a single superior forecasting method. One organization may find regression effective, another firm may use several approaches, and a third may combine both quantitative and subjective techniques. Whatever tool works best for a firm is the one that should be used. In this chapter, we consider forecasting models that can be classified into one of three categories: the time series models, the casual models, and the qualitative models. Time series models. Time series models attempt to predict the future by using historical data. These models make the assumption that what happens in the future is a function of what has happened in the past. In other words, time series models look at what has happened over a period of time and use a series of past data to make a forecast. Thus, if we are forecasting weekly sales of a particular item, we use the past weekly sales of that particular item in making the forecast. The time series models we examine in this chapter are moving average, exponential smoothing, trend projections, and decomposition. Regression analysis can be used in trend projections and in one type of decomposition model. The primary emphasis of this chapter is time series forecasting. One of the forecasting methods under the time series models is the moving average method. So a moving average, also called a moving mean or a rolling mean, is a calculation that relies on a series of averages from data subsets within an entire dataset. So it is frequently used to describe changes to averages. So for our example, we have the number of smart TV units sold for the past 10 years. So let us take a look at our time series. So to get the moving average, let us go to the data tab, and under the analysis group, click data analysis. Select moving average and then click OK. Let us set our input range from cell B3 to K3, which will be our year. Let us set the interval to, let's say, 6, and select our output range to B3, B5 rather, and click chart output and click OK. This would be your moving average. So because we set the interval to 6, the moving average is the previous 5 data points and the current data point. So the graph shows an increasing trend. Another forecasting method is the exponential smoothing. Exponential smoothing is a time series forecasting method for univariate data that can be extended to support data with a systematic trend or seasonal component. So exponential smoothing of time series data assigns exponentially decreasing weights for newest to oldest observations. In other words, the older the data, the less priority the data is given. Newer data is seen as more relevant and is assigned more weight. Smoothing parameters, usually denoted by alpha, determine the weights for observations. Exponential smoothing is usually used to make short-term forecasts, as longer-term forecasts using this technique can be quite unreliable. So in the simple exponential smoothing, the basic formula is shown on the screen. So for our example, we have the number of smart TV units sold for the past 10 years. So for the exponential smoothing, let us go to the Data tab. Under the Analysis group, choose Data Analysis. Select Exponential Smoothing and click OK. Let us set our input range from B3 to K3, which represents the base year, and set the damping factor to 0.1. So this would be your smoothing constant. Let us set the output range to B5 and click chart output and choose OK. So this would be the graph for the exponential smoothing. So because we set the alpha to 0.1, the previous data is given relatively small weight. As a result, the graph shows an increasing trend. Let us now proceed to the other types of forecast, the causal models. Causal models incorporate the variables or factors that might influence the quantity being forecasted into the forecasting model. For example, daily sales of a particular item might depend on the season, the average temperature, the average humidity, whether it is a weekend or a weekday, and so on. Thus, a causal model would attempt to include other factors for temperature, humidity, season, day of the week, and so on. Causal models may also include past sales data as time series models do, but they include other factors as well. Our job as quantitative analysts is to develop the best statistical relationship between sales or the variable being forecasted and set of dependent variables. The most common quantitative causal model is regression analysis, which was presented in Chapter 4. The last type of forecast would be the qualitative models, which will be discussed by the next reporter. So that ends my report, and thank you for listening.